Hey everyone, welcome to Chapter 6, Section 4, Solving Radical Functions. Here we're obviously going to be solving functions with radicals, taking the square root, cube root, fourth root, and so on. But on A, I have an exponential function, well not an exponential, but it has an exponent. It's raised to the fourth power, so how do you get rid of the fourth power? Take the fourth root. And remember, anytime you take an even root, you get a plus or minus answer. So the fourth root of 16 is plus or minus 2. And then it just leaves behind the x plus 1 on the other side. So when you minus 1, you have two answers. You have negative 1 plus or minus 2. So negative 1 plus 2 is 1. And negative 1 minus 2 is negative 3. And that's it. Letter B, if there's stuff on the outside, get rid of that first, okay? Don't add 3, that's on the inside of the radical, okay? So you'd have to get rid of the radical before you could add 3. So that's why the first step is divide by 2. That leaves behind the square root of x minus 3 equals 7. The opposite of a square root is the square or the power of 2, okay? So what you do to one side, you have to do to the other. And I won't do a plus or minus because I'm squaring. If I did a square root, I would do a plus or minus. But 7 squared is 49. Add 3, and you get 52 for your final answer. For part C, well, you have the cube root. So the first thing you might be thinking is, let's take the power of 3 to both sides, but you had this minus 2 on the outside, so just add that over. And then you have the cube root of 2x minus 5. So you're not going to divide by 3. That's a common mistake I hear or I see kids make. Remember that 3 stands for the root. It's not 3 times the square root, okay? So the opposite of the root of 3 is the power of 3. So you got to raise both sides to the power of 3. So you have 2x minus 5 equals 125. And now it's just, solving like normal. I'm going to add 5 to both sides. I'll get 130. And then 2x equals that, so that means I have to divide by 2. And 130 divided by 2 is 65. And that's my final answer. So in this section, I'm going to solve an equation with two radicals. It's pretty simple. If you have two radicals, raise it to the power of that radical. So these are just square roots. So I'm going to square both sides. It's just going to make it go away. You're just going to be left with x plus 2 equals 3 minus x. I like to do these in one step. It's technically a two-step problem, right? So you'd add x to the other side, get your x's on one side, and then get your numbers to the other. So what I say is just cancel one thing from each side, and you can do it all on the same line. So x plus x is 2x, 3 minus 2 is 1, and so now I just divide by 2, and x equals 1/2, and it's over. That's it. Letter B, same thing, it's the square root again, so I'm going to square it. If it were the third root, I'd cube it. But it's not really going to change what's inside it. What's inside you just carry straight down. So I'm going to write 2x plus 5 equals x plus 7. And I'm going to cancel one thing on each side. So I'll minus x, cancel one thing on the right. So I'll minus 5 to cancel one thing on the left. And 2x minus x is x. 7 minus 5 is 2. So the answer is x equals 2. So here I'm going to solve an equation with a rational exponent. So on A, I have 4x to the 3/2 equals 32. So that 3/2 is only being applied to the x, not the 4. So that means you can the first step is rather simple. You can just divide out the 4. And so you have x to the 3/2 equals 8. So, normally when you get rid of a power, you do the root of that power. So technically I'm going to do I'll do the cube root and then raise it to the power of 2. So that might sound confusing. what you're really doing is, the easier way to explain it is flip that fraction and raise that power to both sides, okay? Because remember, this will just make 1, so it'd be x to the power of 1 equals 8 to the power of 2/3. So let's talk about what 8 to 2/3 means. So in the previous videos, I just said that the denominator is the root and the numerator is the exponent. So I need to do the cube root of 8, which is 2, and then I just do 2 squared, which is 4. So that means my final answer is x equals 4. And that's how you do it by hand without using the calculator. So on letter B, I have 3x to the 3/4 minus 2. So always get rid of stuff that you can add or subtract first. So this 3x is in parentheses, right? So that means the 3/4 power is being applied to the x and to the 3. So you can't divide out the 3 until you get rid of the parentheses. How would I get rid of the parentheses? By getting rid of that exponent. So I'm going to flip it and I'm going to do 4/3 to both sides, okay? So I have 3x equals, and remember, the bottom number, the denominator, is your radical or your root. And so I'm going to do the 3rd root of 27, and the top number of the numerator is your exponent. So I'm going to raise it to the 4th power. And so the 3rd root of 27 is 3, and 3 to the 4th power is 81. So I have 3x equals 81. So just divide by 3, and we're back to 27. But that's the final answer. So for part C, the first thing you need to do is get rid of that power of 1/2. Remember, the power of 1/2 is the square root. So I'm going to square both sides. And that makes sense because if I flip it, that makes 2/1, or just 2. So if I raise both sides to the power of 2, I'm left behind with x plus 30 equals x squared. All right. So if you see an x squared and x plus 30, it's starting to look like a trinomial. Get everything to one side. So I'm going to minus x and minus 30 over on the same side with the x squared, because I can factor all that. X squared minus x minus 30 equals 0. What are my factors of negative 30 that add to negative 1? Well, 6 and 5 make 30, and if the 6 is negative, they'll add together for negative 1. So I'm going to say x minus 6 and x plus 5 equals 0. So if you're just setting this equal to 0, x minus 6 equals 0, so therefore x must equal 6. And x plus 5 equals 0, so x must equal negative 5. And those would be my two answers, except that this x minus 5 is technically extraneous. It's making x equal 6 the only real answer. So I will talk about that more in detail as to why the negative 5 is extraneous in the very next little section we have here. But for a quick answer, let's just look at the graph and look at where they intersect. If there's two answers, then they should have two intersections. And so here is x plus 30 to the 1/2, and then x graphed. And they just intersect once, and that's at 6, okay? So if it's only hitting once at the intersection, then there's only one answer, all right? So let's talk more about solving an equation with an extraneous solution. So here I have x plus 1 equals the square root of 7x plus 15. I need to get rid of that square root, right? So I'm going to have to square both sides. All right, so that'll leave behind 7x plus 15 here. And then what does x plus 1 squared mean? it means x plus 1 times x plus 1, all right? So the pattern for these are pretty simple. What's 1 plus 1? That's 2. What's 1 times 1? That's 1. So it's going to say x squared plus 2x plus 1 equals 7x plus 15. Now, the longer explanation is just this. Do x times x, that's x squared. Do x times 1, that's 1x. Do 1 times x, that's 1x. Do 1 times 1, that's 1. What's 1x plus 1x? 2x, see? But once you get a hang of the patterns, you can just do that. So get everything to one side, and then it should still be able to factor. All right, so minus 7x over, minus 15 over, and I now have x squared minus 5x minus 14 equals 0. So my factors of negative 14 that add to negative 5 are going to be negative 7 and positive 2. So I say x minus 7 and x plus 2 equals 0. So I get x equals 7 and x equals negative 2, all right? But that negative 2 is going to be extraneous. So let's examine why it's extraneous. Plug it back in. My original function was x plus 1, so negative 2 plus 1 equals the square root of 7 times negative 2, which is negative 14, plus 15. Well, this says the square root of 1 equals negative 1. And so the square root of 1 is 1, but normally you say, wait, it's plus or minus though. So I think a lot about that too, or that question came to mind too for me. But I'm going to refer you back to the graph. So here, when you look at the graph, you see that, square root graph does curve, and it is possible for a line to intersect it twice, if this line were tilted a little bit. But the intersection is clearly only once, and that is at 7, 8. So if you plug in 7 to the function, you will output 8 as your answer. So there is no intersection at negative 2 with the x plus 1 graph, okay? So same thing with B, we're going to solve this and look at the graph and see which one's extraneous. I'm going to do this one off camera to save time. Okay, so I squared both sides, and then when you distribute x minus 4 times x minus 4, you get x squared minus 4x again, plus 16. So that'll combine to make minus 8x. Again, just add negative 4 plus negative 4, that's negative 8, times it together, that's positive 16. So you can write x squared minus 8x plus 16 and kind of skip that step. But otherwise, get everything to one side. The factors of negative 10x that added to 9 would be negative 9 and negative 1. So I get positive 9 and positive 1. So you get two positive answers. So at first glance, it's like, oh, they're both positive. The other one that was negative, and that one was extraneous. So you're like, they're both positive, they'll both work. If you plug in a 1 here, 1 minus 4 is negative 3. You're going to get negative 3. And if you take the square root, you should be getting positive answers, and yes, I know algebraically the square root can equal a plus or minus, but that's why you really need to look at the graph. And the graph, let me pull it up here. The graph intersects once, and that's at 9, 5, okay? So if it's going to equal, if you have two things intersecting two graphs, it's probably not going to equal that negative 1. That negative 1's probably not going to work. I strongly encourage you to graph it to verify, because it is possible to get two answers because this graph is curved, but most of the time you're going to just get one answer and the other one is extraneous, okay? So that being said, let's wrap it up by doing the last section. Oh, I'm glad I put this on here. You only need to check for extraneous solution when taking an even root, because you can do the odd root of a negative number. The cube root of 125 is 5. The cube root of negative 125 is negative 5. You can do that. But if you typed in the fourth root of 81, you'd get 3, but if you typed in the fourth root of negative 81, you'd get a no solution. So, yeah. Now, solving a radical inequality, well, starts off just like any other equation. Divide by 3, divide by 3. Square root of x minus 1 is less than or equal to 4. So that means I have to square both sides, and I get x minus 1 is less than or equal to 16. If you add 1 over, you get x is less than or equal to 17. And so you're tempted to say that's the final answer. But remember, we can't take the square root of a negative number, and negative numbers are less than 17. So because of that, you have to take what's in the radical, and you have to set that equal, or you have to take that and set it greater than or equal to. The only reason why it's or equal to is because the original one was or equal to 0, okay? Because 0, once it goes below 0, they're negative numbers, and you can't do that, okay? So you need to be aware that if you have a problem that's an even root and a less than or equal to or a less than 1, okay? Because if it's greater than, you don't have to worry about negative numbers. But if it's less than, then you do have to worry about it. That being said, what number minus 1 is greater than 0 or equal to 1? So I say x is greater than or equal to 1. So if you have answers going in opposite directions, you can say it like this. 1 is less than or equal to x, which is less than or equal to 17. That's how you would officially phrase it. But if you were a student of mine and you said this and this, I'd still give you full credit, all right? So yeah, you only need to check for the x is greater than or equal to if the root is even and the original problem is less than or equal to. So this one, I will have to do what I just did, but this one, I will not have to do what I just did because it's greater than and because it's an odd root, all right? So I'll do B real quick. Well, I'll do both of them, but just giving you the explanation right now. So I have to add 4. 3 times the square root of x is less than or equal to 12. So now I have to divide 3. The square root of x is less than or equal to 4. Get rid of the square root by squaring. And so you have x is less than or equal to 16. So again, that encompasses negative numbers. So take whatever's in the radical and set it greater than, in this case, greater than or equal to 0. Again, that's only because the original was underlined. And there's no math to do. X is greater than or equal to 0. It's done. So you can say that 0 is less than or equal to x, reading it from the other way around, which is less than or equal to 16 for your final answer. All right? So on letter C, there's only going to be one answer because it's greater than and cube root. But you got to get rid of that 2 on the outside. So the cube root of x plus 2 is greater than 4, so I'm going to cube both sides. 4 cubed is 64. X plus 2 is greater than 64. Well, minus 2, and so x must be greater than 62. And that's going to wrap up these notes. Thank you for watching. Bye, everyone.